Hi everyone, I am Aashreen Raorane. I'm a senior data scientist at ZS Associates, which is a global tech consulting firm. I work with a major global technological company on their marketing team, supporting production ML models that run at scale. And drift in all of its form is something that I deal with regularly. So today I will be presenting my topic, more than a retrain, how to monitor, diagnose, and explain drift in production ML models. I will also be providing a practical framework to how to think about it. Let me start with a scenario that will probably feel familiar. Let's say you've built a churn prediction model. It's been running in production for months. Sales team use it every week to prioritize who to call. Then one Monday, you get a message. The list looks really short this month. Fewer high-risk customers than usual is what we're encountering. Is something wrong? You check and there's no fail pipeline, no error logs, no red alert, just fewer outputs than expected. Seems like this is what is drift. And the immediate instinct for most teams, let's retrain. But that reflex without any diagnosis can actually make things worse. If the issue is corrupted data pipeline and you retrain on that data, you've now baked your problem into your model. So before anything else, you need to understand what actually changed. And that starts with knowing what type of drift you're dealing with. So there are a few different types of drifts. Before we dig into each case, it helps to understand that drift isn't one single thing. It actually shows up in a few distinct ways, and each one points to a different problem and a different fix. The first is data drift, where the distribution of your input features shift from what the model was trained on. The second is concept drift, where your inputs look completely fine, but the underlying relationship between those inputs and the outcome has changed. The third is prediction drift, where the model's output distribution itself shifts, which is often the earliest visible symptom that something upstream has gone wrong. Knowing which one you're dealing with is really what separates a targeted fix from a blind retrain. So let's go through each one using the same churn example and look at how you would detect it, diagnose it, and resolve it. Okay, so case one. So get that message about fewer predictions. First thing you do is look at your inputs. You pull feature distributions for this month versus your training baseline, and one feature immediately stands out. Customer login frequency looks very different. Values are lower across the board, and your null rate has spiked. You trace it back and find that a recent app update introduced a bug that was suppressing login events for 2 weeks. The data pipeline was delivering incomplete records to the model. This is data drift. The model itself is completely fine. The data feeding it is not. In terms of how to detect this, what you want to be doing is running distribution checks on your key features at every model run. Population Stability Index or PSI is a really useful metric here. It gives you a simple score quantifying how much feature distribution has shifted compared to your training baseline. Pair that with the KS test for continuous features and basic volume and the null rate tracking. And you have a solid early warning system. The goal is to catch this before the business notices. And for resolution, you don't need to retrain yet. Fix the upstream pipeline first. Once your inputs are back to healthy ranges, validate that distributions have normalized, then reassess whether the model needs any further attention. Now let's look at a slightly different scenario. You run all those same input checks. Distributions look normal, null rates are absolutely fine, volume is healthy, but the model is still flagging significantly fewer customers. The inputs haven't changed, the outputs have. You talk to the product team and find out that the company launched a loyalty program 3 months ago. Behaviors that historically predicted churn, that is, reduced logins, fewer support interactions, are now being offset by reward point engagement that they put in. The signal your model learned no longer maps to the same outcome. This is what we call as concept drift. The world changed, and the relationship your model encoded is now stale. This is actually where storing your model outputs becomes really critical. If you're saving your prediction score every single run, you can compare output distributions over time. And if the model is systematically scoring customers lower across the board without any corresponding input drift, that's a strong concept signal. And if you have any downstream outcome data, even lagged Sharp value tracking over time can show you which features are driving predictions differently than what they used to. When it comes to resolution, yes, this is when retraining actually makes sense. But the key question is what you retrain on. You want to go for a sliding window approach, which takes in the recent data that actually reflects the current world, not the historical data that predates the behavior shift. And definitely document what changed and why. That context will matter when you're explaining the new model's behavior to stakeholders. So, we've covered what happens when the data going in changes and what happens when the world changes around your model. Now, the third type, and honestly, this is often the first one you'll actually notice in practice, that is prediction drift. Prediction drift is when your model's output distribution itself starts shifting. In our churn example, maybe the model used to flag around 30% of accounts has high risk every month. Then you check 1 month and it's flagging 8%. You run your input checks, distributions look fine, no pipeline errors, no alerts, but the outputs just don't look the same as they used to. And here's the key thing about prediction drift, it's a symptom, not a cause. It doesn't tell you why something has changed, it just tells you very clearly that something has. Think of it as an alarm that's going off. So, your job now is to figure out what triggered it. The only way to catch this early is if you're storing your model outputs every single run. Because without historical prediction saved, you have nothing to compare against. Once you have that baseline, you can track score distributions over time. Is the model scoring lower across the board? Are high risk predictions clustering in a narrower range than before? The PSI on your model outputs will give you a very clean signal and answer these questions. And then resolution really depends on what you find when you dig deeper. If you trace it back and the inputs have shifted, that is data drift, and we need to go and fix the pipeline. But if the inputs look clean but the behavior change, that's concept drift, and it is time to retrain. Prediction drift is just a starting point, it tells you where to go look first. So, across all three different types of drifts, at some point you're going to decide to retrain, and that's totally fine, and that's often the right call as well. But there's one more step that a lot of teams skip, and it is an important one. Before you deploy the new model, you need to do a version comparison. Not because you don't trust the retrain, but because retraining changes things, and you should understand what changed before it goes into production. There are three checks I usually done. First, comparing the feature importance rankings between version 1 and version 2. That gives answers to what moved up, what dropped out entirely, and many other things. Second, comparing the SHAP profiles. Not just what model predicts, but why, which tells you what it's learned differently. And third, look at a prediction distribution overlap. Are the two models broadly agreeing on who's high risk or diverging significantly? If the differences make sense, given what you know has changed in the world, then you should ship it. But if something looks off and you can't explain it, it's better to hold on and investigate and not deploy until you completely understand it. Because after all, a rollback is much cheaper than a bad model running in production. Now, here's something that I think is really easily overlooked. Your best drift signals don't come from your data. A product launch, a pricing change, a new customer segment entering your pipeline, all these things happen upstream of your features and may cause data drift. And by the time your monitors catch the effect, it's already too late. So, one of the most practical habits you can build is just maintaining a simple change log, not just for the model versions, but for anything that touches your data environment. That is pipeline changes, schema updates, business context. When something looks off, that log is honestly the first place that you should go. It'll cut your diagnosis time down significantly. And beyond that, the best thing you can do is just not wait for something to break before you start paying attention. The teams that handle drift very well usually have built a few simple habits early on. They're monitoring input distributions continuously. They're storing model outputs every run so that they always have a baseline to compare against. And they're doing a version comparison after every retrain without skipping it. And honestly, none of this needs a full MLOps platform. A schedule script and a simple dashboard will get you surprisingly far. So, to wrap up, drift isn't a model failure. It's just what naturally happens when your model is living in a world that keeps changing. And it will happen to every production model every time. The teams that handle it well aren't necessarily the ones with the most sophisticated infrastructure. They're just the ones asking the right questions early enough. Detect it, understand what type it is, and find the root cause, and then make the call. Because you really can't make that call if you're not looking. Thank you.